Hello friends, my name is Dheeraj and I'll be discussing about SRAM. SRAM is a type of RAM which is known as static random access memory or also called as static RAM or SRAM. It's a type of semiconductor memory that basically uses the bi-state latching or also called as flip-flops integrated with them in a circuitry to store each byte of data. SRAM exhibits data remnants. Data remnants means the inability to store the data for more amount of time, or we can call it as the volatile in nature, which means that the data is lost when the memory is not being supplied. Where actually can we use such a kind of RAM? It can be used for cache memory. Cache or those kind of memory units which have no usage when we end the application. So after closing our devices, this entire cache memory is lost. Whereas we take the case of the DRAM, it is a permanent data which is only lost when we delete the data from it. So in fact I would like to say that SRAM is faster in nature, more expensive than DRAM, but helpful in storing CPU cache and other computer main memories. It may be dense, but it has higher capacity and also handles low cost appliances such as memory applications in personal computers. Now going ahead, let us understand how to develop a SRAM. Development of SRAM is done by two categories. One, by the usage of transistors. Second, by usage of MOSFETs. Now first, going with the transistors. Transistor to transistor logic technology is being used for developing SRAMs and for integrating it with the flip-flops to make a total RAM cell. Now what is transistor to transistor logic? It is a class of digital circuitries built from the bipolar junction transistors and resistors. Thus, they basically are helpful for making a logical gating function of AND function. Why do we need transistors? Transistors we need because of the amplification nature they provide when signalizing the output. Now, where it was found? This kind of transistor logic was actually found while developing an integrated circuit at 1963 in Sylvania by Texas Instruments. Later they found out that this TTL integrated circuit technology can be used for developing RAM cells along with the flip-flops for storing of data and for better accessing it. This large number of cells, when arranged in a huge number of columns, they make one entire memory cell. Now let us go in brief with the TTL SRAM. TTL SRAM consists of two bistable flip-flops that are connected to the internal circuitry with these transistors, and they are closed in a very stable state. So when there is no addressing of data or when there is no information passing through this SRAM, these two transistors are closed and the data will be at a stable state and will be launched without a flip-flop. So as your flip-flop needs power supply to keep the information, the data in the RAM cell is volatile, that is, it is lost when power is removed. However, there is no leakage of data like in the DRAM. So the SRAM gives us more security, requires a refresh cycle and creates better advantage than DRAM. Now going ahead to MOSFET. MOSFET means metal oxide semiconductor field effect transistor, SRAM. Now why do we need then a TTL technology? Even though we use transistors in TTL technology, MOSFET creates an advantage by providing better signal amplification than transistors. So it creates a very vital role in maintaining cache memory for immediate processing of intermediate data. Now how do we get the organization? Organization in SRAM is basically handled by single decoders and double decoder interfaces. Thus when a message is received by the decoder decodes the message, and the process of functioning like the data manipulation and other processes as given by the user to the SRAM is being processed accordingly. Now going ahead, the major advantage of using this SRAM than the TTL technology is the faster operating speed and the better amplification work done by the MOSFETs. Thus, it creates an extra speed advantage in storing the cache memory and accessing it from the cells. But due to high manufacturing cost and higher integration with the flip-flops. It cannot be used as the main RAM cell in PCs, thus prohibiting us from the usage of the high technical MOSFET RAMs, and rather TTL SRAMs are being followed. Now I would like to wind up this video by creating a small differences between SRAM and DRAM. SRAM, even though SRAM is more faster and more reliable than DRAMs, DRAM has lesser access time, that is the time taken to do the read and write operations from the memory, that is about 60 nanoseconds, but SRAM has a better access time of 10 nanoseconds. In addition to the access time, we have the cycle time. Cycle time of DRAM is much shorter, but SRAM is even more shorter because there is no pause between the accesses. Unfortunately, SRAM being more costlier than the DRAMs, we cannot use SRAM as the main memory component where we can store all our personal data and information, but it is often used as memory cache for storing intermediate data and other stuffs. As we know that SRAM is being built under bi-state latching circuitry with the transistors, MOSFETs and flip-flops interconnected with the proper circuitry to store each byte when compared to the DRAMs. SRAM doesn't have any capacitor to store the data or to hold the data that is being gathered to it. Hence, SRAM works without refreshing and without wasting any time on it. So because of the absence of a capacitor in SRAM, the data is lost when there is no electrically power supply. Thank you.